Okay, so now we've gained some intuition about what all this for all stuff means. Let's ask a couple of questions that we can answer pretty easily, I think. One is, what's it mean in general for an arrow D from B to omega to the power of A to write that for all A after D is TB, as in true for arrow after exclamation mark B? Well, it's all about interpreting this arrow D, really. So we can, I mean, it's an arrow into omega to the power of A. So we can say, well, what if there's an arrow? Well, there will be an arrow L that it's the transpose of. And we can get L as E after D times 1A. And that's going to be an arrow from B times A to omega. So we can say that that L is the classifying arrow, chi of R, of some subobject R of B times A. So then we can rewrite D as chi R transpose. So D equals chi R transpose, where R is the subobject classified by the kind of anti-transpose of D. Well, all right then. So what does this mean? What's it mean to write for all A D equals TB? Well, it means that chi of the name of TA operating on D gives true. In other words, it means that D, which we know is chi R transpose, is in the name of true A. Now, if we just put a 1B in there, which we can just without changing the meaning, we can think of that as S. And then if we go up here, we see we have the same expression, and we showed that this was equivalent to saying that S times 1A is in R. So for us, S is 1B, the identity of object B. So what we have as a conclusion is that this is equivalent to saying that 1 times B times 1 times A is contained in R. In other words, R is full. R is 1 times, is the identity of B times A. And if you think about it, this makes some sense, because how we'd normally interpret this, like in set, for example, we'd be saying that what's happening is we're sending every point of B to a point of omega to the power of A, which corresponds to the kind of full subobject. So that means this must correspond to a kind of full relation, because it's saying that every single thing in B is in relation with every single thing in A. Okay. Now let's do another case, which I think is a slight generalization of what I've just gone through the algebra of, but I think the algebra still works just as well when S is not a monic. So if S is just an arrow from zeta to B, I think all the algebra still holds. So we have that for all A, what's it mean? So and when we ask the question, what's it mean to write for all A, ds is true? Well, that means that ds, which is equal to chi r bar of S, is going to be in the name of true. And then we can, again, correspond this with partway through our proof up here. Except now S is not monic, but I don't think that matters. And we've still got this expression. And we see this is equivalent to saying that S times 1A is in this relation R. So what happens, for example, when S is a point? In other words, when zeta is a terminal object, where zeta is the source of this arrow S. Well, in that case, we have for all a ds is true, if and only if S times 1a is in R, which basically means that this point here of B, this point S of B, is in the R relation with everything in A, which is just what we thought, because like that was one of the things that I claimed back up here. Okay, these points, okay, I'm using a Q here instead of an S, but these points for which, so this is now like D, and this is like S, and these well, if we had a single point of that, it'd be like S anyway. And say for all a ds gives true, that's saying that this point of B is in this R relation with everything in A, which is just what's happening, because that means it's getting sent to a, I mean, this is in a set case, it's getting sent to a full sub-object and then getting sent to true.